Good afternoon. My name is Marek Behún, and I'm going to talk about what I have been working on for the last few months at work. And that is about porting U-boot to a modular device, a device which into which different modules can be plugged, like USB or something like that, but it doesn't work like USB, so a different approach had to be chosen. Here we have the contents about the presentation. So first about me, I was born in Slovakia, 1991, using Linux from 14. Currently I am studying computer science in Prague, and for the last 2 years I have been working at CZNIC on project Turis. And the problem which this presentation is about was solved for Turis MOX. So, what is device 3? I don't know how people here are proficient in the U-boot, so let's hope this is not too much for you. The device 3, the operating system kernel has to know how different computer components are on a board are connected to each other. And for this, device 3 was the standard for device 3 was created. Device 3 is as the name suggests, is a graph in which each node represents one device, has properties about what type of device it is, which driver should be used, and which interrupt lines are connected to the device, and so on. Actually, it's not a tree in graph theory, because the edges can form a directed cycle sometimes. So it should be maybe called a device graph. Well, what if some components are pluggable? For example, USB is pluggable into each device which supports USB. If you have a router or a Raspberry Pi, you can also plug PCI cards, PCI Express cards in computers, and nowadays SDIO can be used. So you can plug a Wi-Fi card into the slot for SD cards. But what if the components which we are talking about aren't plugged via such a bus that supports such a change? Then device 3 has to be changed. If you have USB devices, you do not have to tell the operating system which USB device is connected, because USB supports self-identification. So the operating system can read from the USB device what type of device it is. But and also from SDIO and PCI Express. But if you have, for example, Raspberry Pi with the HiFiBerry shield, or if you have there are many kinds of shield now. I have read about TV head for Raspberry Pi. If you have something like that, then you have to change the device 3, which with which U-boot boots boots Linux. So, and our device exposes several interfaces, like USB, PCI, and Ethernet via one connector. And there are several different modules which can be connected to the device. and they can also be connected in some of them can be connected multiple times. For example, switch module can be connected more times, and then you have multiple ports, Ethernet ports. The topology of how the topology of how these modules are connected can be read via SPI, via a SPI shift register. And the problem I was solving was how to let the kernel know in an elegant way which modules are connected. Normally, for this kind of thing, there are device tree overlays. Device tree overlays are special kind of device trees, device tree binaries, which the bootloader can overlay over a normal device tree, and it will somehow change the original device tree binary. It will, for example, it will add some devices or create some edges in the device tree so that the kernel will know that something is connected additionally. Here is a screenshot of listing of all the different device tree overlays supported by Raspberry Pi. So if you look into the /boot directory /overlays on your Raspberry Pi, you can find all these overlays and more. Here are only 14 listed. So the question is, can we use device tree overlays for each module on our board? And the answer is no, because the parameters for the device tree for each module are dependent not only on which module this is, but also where in the topology it is connected. So if it is on the second place after some different module, then the parameters have to change for this module. For example, if I have a module for the fourth one for SFP cage, it's dependent on if it is on, for example, on the third place, or if it is directly connected to the CPU module, because there are GPIOs on the SFP cage, and the GPIOs can be read via the SPI line, via which the topology is also read. So we can't use device tree overlays for this problem. Really? At first I actually used device tree overlays, but as you can see, the number of different device tree overlays grows rapidly because of each configuration has to have its own overlay. So, for example, if I connect three switches with chipset Peridot, then I have to have different device tree overlay as when I connect only two. And this will grow more rapidly because the SFP module can also will also multiply the number by 2. So so we could use device tree overlays, but it's not very nice and elegant. Fortunately, U-Boot has this feature that each board-specific code can use. So for different boards in the U-Boot source, you have a special code for booting them, and one of the functions you can write for your board is FT board setup, which will which will pass you the pointer to the device tree loaded by the user or by the script booting the operating system. And in this function, you can change the device tree, fix it or something, remove nodes, create nodes, and so on. So at first, I tried to create the whole nodes for each module in this function. So the main device tree in the kernel for the kernel didn't contain nodes for the modules, only for the CPU module, not for the pluggable modules. And my code in FT board setup created all the nodes for all the connected modules. But the result was almost 1,500 lines of ugly C code. Ugly. If I wanted to check for every possible error, then it was ugly. So, and many times it was the same thing, but something was different. So you couldn't write a special function for everything. It couldn't be squashed by using functions. So I asked myself how to do it more. So the code, how to do it so that the code will look more nice. And I have decided that the right metric was minimizing number of the changes that the code in U-boot has to do in the device tree, so that it can boot correctly the device. So I decided that I will write a node for every module inside the main device tree in Linux, but I will use status disabled for those nodes so that kernel will ignore them on default. And on boot time, U-boot in this FT board setup function will just look at the SPI line, discover which modules are connected, and it will just change status to OK on those nodes which are connected. And also, sometimes it has to change something more because of what I talked about some slides ago, because some modules need special configuration about because of the position where they are. So the result from this was only under 250 lines of additional C code. I have a screenshot here. It looks, in my opinion, a lot nicer than the original 1,500 lines. We also add 600 lines of device tree code in the main device tree in kernel, and the status of this is that the patches, some of them are already reviewed on kernel mailing list. So it looks like it will be accepted into kernel as well, and it was already reviewed in U-boot. Here in this screenshot you can see that I have to change the name of the node which exposes GPIOs for the SFP module. So The advantages and disadvantages of this solution. Well, in my opinion, the advantages are that there is less C code, new C code. It is also more readable. I actually had the 1,500 lines of code a few months ago, but I didn't know that I will be making this presentation, and I removed it. But if I had it, you would see that the code was ugly. And another advantage, in my opinion, is that when some developer makes a change in a driver in the kernel, for example, for the switch in the DSA subsystem, and this change would have to also change device trees somehow. Then if the whole device tree is in the kernel repository, then they will also change it, and I won't have to change it on my own. The disadvantage is, well, we are not using overlays, and they are meant for this kind of thing, but they couldn't be used in efficient way, so I decided not to use them. A bonus slide. One problem which I had to solve, which I needed to find a solution for. On our board, SERDES lines, the driver for initialization of SERDES lines is loaded before SPI driver. This means that SERDES lines are initialized before, and when I initialize the SERDES lines, I have to know the speed for each line. For example, if SFP module is connected, then the corresponding SERDES line has to be for 1 gigabit. But when switch module is connected, the corresponding line has to be at 2.5 gigabits per second. And when the SERDES initialization is done before the SPI, then I cannot know which module is connected. So there were two solutions for this. One solution was to write a proper driver for SERDES initialization. By proper, I mean that the SFP node in U-boot should, in the device tree, should have a pointer to the SERDES line, and the driver then would have known which speed to use. If it is connected to the SFP line in the device tree, it would have known that it should enable the SERDES line on 1 gigabit, and if the switch node is connected, then it would have known it should enable it on 2.5. But completely rewriting the SERDES initialization code was too much work for my time, so I decided that I will write I will solve this problem by writing my own tiny implementation of SPI communication. It is only 35 lines of code. I write to some registers directly on the CPU, and then read some registers, and I have read the first 10 bytes from the SPI, so that then I know which modules are connected. It is not this solution is not very elegant because I have to. There is a proper implementation of SPI communication in U-boot, and I had to write my own. So it is called the duplication, but this can be removed when we have correct CERDES initialization driver. Thank you. Okay, that's all from me. Any questions? Okay. Yes?
Is it possible to get some kind of notification when another device is attached?
Our device does not support hot plugging, only booting. I have actually talked today with a colleague if it was possible, if it were possible. The problem is that our device, if you connect something, the voltage will drop for a little time and the CPU will reset. But we have been thinking about if we could do hot plugging, and kernel supports device tree changing online. So we would have to work on it. I would have to write drivers for this, but it could be working. But our device does not support it.
For now.
The board would have to be changed. Maybe next version.
Okay. Thank you.
Welcome. Questions? Okay.